Hi guys, you're welcome to today's class, still on Atwood machine. Today we have another question here. It says the masses shown in the figure below are tied to opposite ends of a massless pulley. Find the tension in the rope and the acceleration of the masses. It says take G equals to 10 meters per second. Like I always say, if it's stated, it's stated. If it's not, you assume G to be 9.8 meters per second. Now, let's see what we have here. Say given the solution, given, we have that the first mass here, M1 is 25 kg, M2 is 35 kg. Acceleration due to gravity G is given at 10 meters per second. We are asked to find the tension and acceleration of the masses. Now, solution we have here for 25 kg load, we have summation f of y equals to ma. F of y equals to ma, and weight here is mass times acceleration due to gravity. Weight will be the mass, say 25 by 10, which is the acceleration due to gravity. Therefore, weight here will be 250 Newton. Now, back to the question. As you can see, this is actually still going like this because the weight here is greater than the other weight here. So the tension here is more, and here too, to bring this down. The weight is coming down like this, while this one is going up because this one is greater and dragging this down. Now we have here that tension for the weight of 25 kg, tension will be equals to or minus weight equals to mass times acceleration due to gravity. Tension minus the weight here is 250 equals to the mass of 25 multiplied by a, that's 25a. This is equation 1 as usual. Now for 35 kilogram weight, we have here that weight is greater than tension, that will weight minus tension equals to ma. As you can see, the weight is greater than tension. That's why, because to the side, the weight is greater than the 35 weight is greater than 25 weight. So it will overwhelm tension, thereby pushing this one up and making this tension to be the rope here to be more tensile. Now, W weight minus T equals to MA. Therefore, weight here is mass acceleration due to gravity, and the weight will be, the mass here is 35 times 10. Weight will be 350 Newton. Therefore, you have here that 350 minus T equals to 35, 35A. Now, from equation 1, we have that T is equals to 25A plus 250. Let's designate this as equation 3. Therefore, we substitute equation 3. Substitute equation 3 in 2. We have that remember, equation 2 here, equation 2 here will be 350, and 2 here will be 350 minus T equals to 35A. So let me designate this to equation 2 so I won't be confusing. So 35A. Therefore, we have 350 minus tension, which are substituting this 25A plus 250 equals to 35A. Now we open the bracket. We have 350 minus 25A minus 250. Remember, we open the bracket. Plus 250 equals to 35A. Now we collect like terms. We have minus 25A. This crossover to this side becomes minus 35A equals to 250 minus 350. Now 20 minus 25 minus 35, we will have minus 60A is equals to 250 minus 35, or 350 rather, you have minus 100. Therefore, acceleration here will be minus 100 over minus 60. Minus, cancel minus, and acceleration will be 100 divided by 60 will be 1.67 meter per second square. Therefore, acceleration equals to 1.67 meter per second square for stability. Now we are also asked to find the tension. The tension here equals to, still from equation 3, we have tension to be 25A plus 250. T here, which is tension, will be equals to 25 substitute A to be 1.67 plus 250. Now if you multiply 1.67 by 25, you will have 41.75 plus 250. Now if you add 41.75 plus 250, you have tension here to be 291.75 Newton, as simple as this. Thanks for watching, and watch out for more problem solution on Atwood machine. Bye.